Okay, magandang araw sa lahat ng mga nanonood ngayon. So this will be a video on which will be pretty much a walkthrough for the combined module for the PIC32 timers and CCP. Although I'm planning on having two separate videos for the timer and the CCP module para rin hindi masyadong mahaba yung recording for me. And pwede kayong magkaroon ng konting break in the middle. So, yeah, let's proceed. So, yeah, so yung mga usual notes. And so, ang objectives natin for this module is to properly configure the PIC32 timer modules, and we have to properly configure them to have a specified period. So, ano yung period at ano yung timers na yan? So, we'll find out later. And then next is we should be able to use the timer module to generate delays with both polling and interrupts. And then next is to call a periodic subroutine using the timer module with the interrupt as well. And then use the second part of the module is to export the functionality of the CCP module of the PIC32, and to use the integrated output compare or OC module and configure it for PWM and use it to modulate the brightness of an LED. So yung pinaka-simple application ng PWM. So yun yung medyo summary ng contents ng ating module for the week, I guess. So introduction. So timers, as the name suggests, allow the microcontroller to measure periods of time. So nagagawa to ng microcontroller by using a counter basically ng clock cycles. So bibilangin mo yung pumapasok na clock cycles. So for example, if meron akong timer block dito, timer. And then may input tayo na clock signal sa kanya, high, low, high, low, high. So basically si timer ang ginagawa niya lang is kinakount niya yung number of high pulses. So after 3, pwedeng high, pwedeng low, or most of the time titingnan actually yung transitions. So kung nga rin nagkatatlong down transitions, ang timer value natin is 3. Tapos, so kung meron pang isa pang pulse dyan, yung timer value natin is 4. So basically, binibilang lang natin kung ilan yung pumasok na transitions sa ating timer block. And if alam natin yung system frequency natin, kung alam natin yung frequency ng input, alam natin kung ano yung time na makukuha natin based sa number of clock cycles na nangyari. So basically, ganun gumagana ang timers. So may extra video here by Kevin Lynch if you need more information. Then moving or expanding on that, ang CCP or Capture Compare PWM module is basically a timer module with extended functionality. So yung input capture, it provides us a way for the microcontroller to capture a specific moment as an input changes. And then yung output compare naman is compares the timer register to a specified value and toggles its output based on the result. So mas may get siya to later on if may example na siguro on these modules. And then yung pulse width modulation, if familiar na kayo, actually hindi yata true yung second part dito since medyo shortened module tayo, but basically pulse width modulation is meron tayong pulse train and minomodulate or binabago-bago natin yung pulse width. So more on that later on. So first, let's talk about the timer. So of course, pinaka-importante sa timer is yung amount of time na i-contain niya. So the PIC32mm contains a total of 7 16-bit timers. So 16-bit means yung maximum na kaya nilang i-count. So kung meron kang total of 16 bits, that is 2 to the 16 yung ating maximum count. So that is approximate, that is 2 to the 6,500, 65,536. So yun yung maximum number of clock cycles na count natin. And then 2 of the 16-bit timers. So we have one standalone 16-bit timer. And then we have two 16-bit timers in each of the 3 CCP modules. So 2 times 3 is 6 plus the standalone 16-bit timer. That's a total of 7. So for the standalone timer, meron tayong 3 registers na tinitingnan. So T1 control. So kung gusto nyo tingnan yun sa datasheet, ito yung T1 control register. So meron tayong bits dyan to control yung kanyang operation. Kung gusto mo siyang i-on, kung ano yung ginagawa niya dapat pag idle, kung other options dyan, usually hindi mo naman ginagalaw, pero it's good to know that there. So yung mga tinitingnan nyo usually dito is ito, external clock selection. If gumagamit tayo ng external clock para dun sa timer. And then yung tinatawag natin na timer prescale bits. So makikita natin kung para saan yung prescaler later on. And then, ayun, kung kailangan ng synchronization signal and yung clock source, kung external clock ba siya or internal clock natin. So apart from dun sa control register, meron tayong timer value register. So ito yung value ng counter. And then yung period register or yung natitrigger pagka rollover. So yung operation ng ating timer is ito, can be summarized sa block diagram dito sa ating sa ating datasheet. So essentially meron lang ditong input na dadaan sa prescaler. So para saan yung prescaler? So pag 1-to-1 ng prescaler, pag yung input dito ay isang pulse na ganyan, ang lalabas dito ay exactly as is. Pero pagka yung prescaler natin is 8, kailangan ng 1, 2, 3, sorry, 4, 5, 6, 7, 8. So kailangan ng ganyan katagal bago mag-transition ating output. So basically, kung gaano katagal, so essentially, 8 cycles na input, pag dumaan sa 8 na prescaler, 1 cycle lang siya sa output. Pagka 64 cycles ay 1 cycle sa output. Pag 256 cycles ng input is 1 cycle ng output. And yung output ng prescaler na yon, siya yung pumapasok sa timer. So every time na mag-trigger si input, basically si timer 1, ang value niya nun is yung value or yung number of pulses doon sa input. So if meron tayong 1 and 2 pulses, timer value natin would be 2. And then ang period register naman natin, siya yung tinatawag nating siya yung nagde-determine na tinatawag nating rollover, na pag si timer nag-equal na kay PR, magkakaroon ng rollover, magre-reset yung timer. And yun din nag-generate ng interrupt. So we can see this in action by adding this code sa ating MPLab. simulator. And so, andito na siya. And then, so naka-comment out lang yung pag-turn on sa kanya. And then, mag-add tayo ng while loop dyan para hindi siya mag-end agad. So, let's just have yung this one as my main project and simulator. And note na yung simulator natin as a instruction frequency of 4 megahertz. Lagay lang tayo ng breakpoint dyan. So, after dito, I guess we can add a breakpoint din here. Then, dito sa watches natin, pwede natin i-watch yung timer value. So, tanggalin lang natin yung iba para hindi masyadong nakakalito. So, yan. So, yung timer natin is nandito sa watch. And if we debug, and run. Medyo matagal na. Ayan. So, ang prescaler natin dito is TCKPS ay nakaset to 1. So, based dun sa datasheet, that means a 1 to 8 prescaler value. So, which means after 8 cycles, 1, 2, 3, 4, 5, 6. Okay. So, naka-8 na nga siya. So, clear nga natin. 1. So, after every step into, meron tayong 2 clock cycles. So, 1, 2, 3, 4. Magkaka-increment tayo sa timer. So, notice here siguro yan, stopwatch count, 205 cycles. 1, 2, 3, 4. Nung naging 213, or from 205 to 213, nag-increment yung timer value natin by 1. So, 1, 2, 3, 4. Nag-increment siya ulit. Kung palitan natin yung prescaler to 0, which means 1 to 1 yung prescaler value. Pagka sinimulate natin, you can observe na mas mabilis lumaki yung ating timer value. So, ayun, let's stop na. So, after ma-issue ng command na on, magsa-start na mag-increment, although not, parang meron pang 1 period bago siya mag-start talaga. And ayun. So actually, from yung previous natin stopping point, 179 cycles, 184 na ngayon. So we can clear this. Kaya may 5 dun. So kung yung timer value natin 5 ngayon, and ngayon 7 to 9. So you can see na yung difference between yung stopwatch natin is 186 and 188. So ayun, kung ilan yung cycles na nagaganap, yun yung timer value natin. So ano naman yung timer period? So let's say iset natin si PR1 to a low value, let's say 30. Gawin natin hex. And pwede rin natin siyang i-add as a watch para ma-top natin. Excuse me. And then you run it. Ayan. So si PR value is 30, si timer 0, si timer 1 starts at 0. Let me just step into the program and let it run. So notice here, okay, nagpo-proceed normally, nag-increment up si timer 1, nasa 0x13, 19, 1B, 1D, 1F, 21, 23, 25. And then ito. So from 2F, notice here, yung susunod na value niya is naging 0. Kasi umabot na tayo sa, naging equal na si PR1 at timer 1. So bumalik sa 0 si timer 1. So yung tinatawag nating rollover. And ngayon, yan, nakita natin, nag-increment ulit siya paakyat. And actually, yung papansin nyo, even number siya ngayon. Kanina, odd number siya. Kasi meron tayong sobrang count kanina. So, yeah. So, ayan. So, nag-match na si timer 1 at saka si PR1. So, yung next value ni timer 1 dito will be a 1 na. Or actually 0. Pero since may dalawang cycles between yung ating steppings, nandun yung isang cycle para dun sa rollover bago siya mag-count ulit ng 1. So, ayun. So, to have a rough idea kung paano yung... So, essentially, yung isang timer rollover, siya yung tinatawag natin na timer period. And we can compute it by adding 1 kay PR value and then multiply it by the prescaler, which is in this case 8, and yung instruction frequency. So in this example, 8 megahertz yung clock or yung instruction frequency. So PR value of 24999 and a prescaler value of 8 will yield 25 milliseconds na timer period. So, note here na pwede natin gawing prescaler natin 64. Pwede natin gamitin na period register is 3124. And we can have the same results. So, choosing the... so, parang walang isang tamang sagot for the prescaler. Although may corresponding consequences or trade-offs yung paggamit ng mas mataas or mas maliit na prescaler value. And you'll get to see that later on. So siguro let's have a more concrete example that uses the timer. So, ayan. So ang first natin na pwedeng gawin dito is using the timer as a delay. So after no configuration, we can set a while loop na just compares timer 1 at saka PR1. And because of this, masastock siya sa while loop as long as si timer 1 is less than PR1 or yung period register. And then makakawala lang siya sa loop pagka si timer 1 nag-equal na siya kay PR1 eventually. So we can add this sa ating and we can add something else doon sa ating program to have it do something else. So for example here, magta-turn on yung LED and then turn on natin yung timer and then wait for the timer to reach PR1 and then turn off yung ating LED and then go to an endless loop. So first, pwede natin siyang ilagay sa ating main code. Replace lang natin siya dito. Ayan. And then balik natin siya sa original na 1 at saka four, 9. And then we can have breakpoints here dun sa pag-turn on ng LED tsaka pang-turn off ng LED. And ayan, siguro sa simulator, we can first check out yung results sa ating so yun, ang nasa nandito sa module is ang input clock ay 8 megahertz and 25 milliseconds siya. However, yung simulator natin dito is naka 4 megahertz. So we expect yung ating timer matapos siya after 50 milliseconds. So, yeah. Let's find out if tama nga. Hopefully, tama nga. So, lagyan na stopwatch. Una siya nag-stop after. Ayan. 189 cycles. Pero, ayun. If we let it play out, ayan. So, we get to the next command at approximately 20,000 instructions, which is 25,000 plus times 8, which is yun nga, nasa 50 milliseconds. So pwede mo na lang siyang i-fine tune since may konting delay, since mayroon tayong comparison dito, hindi agad na turn on yung timer, etc. etc. Kaya hindi siya nagiging exact na exact. Pero ayun, medyo malapit naman na siya. Hindi na masyado masama. So yun nga, pwede nga sabi natin dito, we can use a prescaler na 64 or gamitin natin si 10 or TCKPS na 2. And then yung ating PR register na 3124. And then we should be able to observe the same amount of delay. Let it play out. So nasa 4, nandun din siya sa around the same range na 50 milliseconds na delay. So pag in-upload mo to, gawin natin yung starter, yung ating DevBoard. Ang makikita niyo sa DevBoard ay sisindi lang na mabilis si LED1 and mamamatay siya. Ayun, yun na yata yung nag-spark siya mabilis. So since walang ginagawa yung main loop natin dito, you can reset the program by pressing yung mclear. So pag pinindot ko si mclear, magre-reset yung program. So pagka-pindot ko sa kanya, we'd expect na iilaw si LED1. Hindi yata nakita. Medyo naglalag yung video. Hello? So, I guess may konting lag yung video. Hindi natin makita yung hindi siya ganun ka snappy. Well, I guess we can move on to the next example, which is mas madaling i-observe, or we can first look at this. Pwede natin makita sa logic analyzer din yung ating results. So, and let me just make sure na I have it enabled. Simulator. Apply. And then trace. Enable trace. Then dito sa logic analyzer natin, let's just have RA0. Yung ating LED1. And di ba meron tayong limit na 10,000 instruction cycles yung makikita. So, baba lang natin yung prescaler to 0. So, debug lang natin siya. Run the simulation. And then the user program is running. Ay, ba't hindi siya nagkaka-breakpoint? Disable yata yung breakpoint. Dahil put ako sa board. So let me just pause it. And then, yeah. Feel free to skip ahead if you're watching the video. And so we'll start with 0 after maging 1. We'll transition to 1. See RA0. And then, ayun, basically, padaanan lang natin siya sa for loop. Nakakatch naman siya ng breakpoint dito. So, ayun, after a certain amount of delay, bababa yung signal. And siguro padamihin lang natin yung ma-execute to see it better. So we can add cursors here sa start and sa end. And you can see here yung delta in X is 3129, which is approximately yung sinet natin na period natin, 3124. Now we can, pag ginawa natin itong 8, you can expect na yung delta would be nasa 24,000, kaso 10,000 lang yung limit natin, so hindi natin makikita. Pero we can set it siguro, for example, 249. Or sige, 24 na lang para mas madali. 24 times 8. So 200 cycles. So we can expect na 200 cycles yung difference between yung transition to the on and to the off state. Yan, on, and then off, and then bigyan pa natin siya ng more cycles para makita natin yung pulse. And then we can set a marker sa start, set a marker sa end, and then delta is around 190 or 224 or 25 times 8. So, yun. That would be yung ating, ayun. So using the timer as a simple delay, we can extend it by, ayun, pwede tayong mag-chain multiple times. Pwede natin siyang i-off pagka hindi natin kailangan. And then i-on na lang natin pag kailangan natin ulit yung delay. And then hintayin lang na mag-roll over yung timer or mag-reach ng certain value. So it doesn't have to even be yung PR value. So, pwedeng kahit anong timer value lang. So, yun yung may fixed delay for a timer. And then we can also use it to generate a periodic subroutine. So, for example, here, I want to toggle the LED every time na mag-roll over yung ating timer. So, recall na pag si timer 1 nag-equal kay PR1, babalik siya kay 0 after the next cycle. So we can take advantage of that. And then, ayun, pagka nag-0 si timer 1, let's toggle yung state ni LED 1. So let me just copy this code here and then stop ko lang to. And let's have a breakpoint whenever we toggle. Para pag makita natin dito, sa logic analyzer yung pag-toggle ni RA0 or ng ating LED. Yeah, so yun, nag-toggle na siya. And it should toggle again. And again. And again. So parang yung lab exercise 1 nyo lang. And then you can see na medyo regular yung distance or yung pulse widths. And yun ang ating expected. So can take yung difference dito. And you can expect it at around 200 cycles, which is yung sinet natin na PR value. And then pwede rin natin itong i-upload sa ating Pickit. So ito ko lang yung configuration to upload it to the pick. And then taasan natin ng konti yung delay. So yung kanina was 24999 for 50 milliseconds, which should be a bit noticeable. Medyo masakit lang sa mata, pero noticeable. And check it out. Okay na siya mag-program. Feel free to skip a few seconds. So I don't think noticeable siya, pero nag-blink siya ng mabilis. Medyo mababa yung frame rate ng ating camera. Let me see if kaya ko. Well, you know what? Let's just increase na lang natin yung prescaler value para bumagal siya. And hopefully you can see that change sa ating board. So parang medyo may mabagal yung ating camera. But parang hindi na siya sumisindi. Pwede naman natin siyang, pwede naman PR yung taasan natin. 6, 5, 3, 5, 5. Ayan. So, I think mas kita na naman na nagbe-blink siya ngayon. Ang lag ng ating video. I might try to explore other options para dito. Reset ko. Refresh ko kaya. That looks better. Ayan. So, yeah. Blinking light. Tama sa Pasko. Okay, what's next sa module? So yun, I think I was able to show it na sa simulator. And ayun. So dito binago ko yung ating PR value. And you should be able to compute ano yung bagong timer period natin. So ang first exercise dito is, baliktad naman, may gusto akong delay. And you have to determine the prescaler and the period register value to meet that certain delay with the clock frequency na given. So just a clarification, yung prescaler value is it will be the actual value. So let's say here, kung yung tanong is for 8 megahertz and then for 50, so we know dito sa unang example, if we have 24999 and then prescaler of 8, we get 25 milliseconds. Ay, kailangan masaktin. So, we know. So, 25 yung kanina. So, 50 dito. We need the same prescaler na 8. And then we can use a period register na 49,999. So, double nung 24999 kanina. So, some Common mistakes here is nakalimutan yung extra +1 here to account for since kahit mag-equal na si timer 1 at si PR1, kailangan pa rin ni microcontroller na isa pang cycle para i-reset si timer 1. So doon dumadating yung +1 for reset delay. Although in some cases, medyo negligible yung effect niya, it's a good practice to account for it every time. And then another thing is, yung prescaler values natin, hindi sila pwedeng, hindi lahat ng maisip yung value is possible. So for the timer 1 module, meron lang siyang either 1:1, 1:8, 1:64, or 1:256. So outside those values, wala tayong available na prescaler. So yun yung dito sa exercise 1. So in this next section, it's about playing with the prescaler and looking into what happens if we choose a small prescaler value or a big prescaler value. So ito una, let's set si prescaler to be 1:1 or 0 yung value ng ating register. And then si PR2 ay 249. And we'll just use the simulator for this para makita natin yung waveform talaga. So, lipat ko lang to the simulator. And apply. Double check. Enabled yung trace. Yes. So, 0249. Meron ito. Let's just run it. So let's watch ahead here. So ang gusto natin gawin dito is to view a cycle na 1,000, 10,000 cycles. Sakto. Yeah. So we're expecting here yung difference nitong dalawang edges natin should be around 249 since yung prescaler value natin is 0. But apparently every 747 values or 747 clock cycles siya toggle. So yun, medyo may mali. So actually na-replicate natin yun nandito sa module. So anong sinasabi dito? So you may try and restart the simulator, which is a usual case. But in this case, medyo same yung may expect natin result. So this is because our timer is ticking after every instruction cycle that occurs. So siguro we can observe here, meron tayong watch for the timer values and the period register values. So can see siguro in this case na si timer value parang nagsiskip siya by 3 bago mag-check ng timer value. So nagkaka-case na tagal naman. Let's just force a rollover. Eto. So, F8 na siya ngayon. And, ayun, sakto naman. During the check, 0 si timer 1. So, nakapag toggle siya. Pero, let's wait for another rollover. Sakto tayo dun. Okay, lumampas naman na. Ayan. So, di pa pala ako lumalampas. B5. Okay. Ayan. So, nagka-timer rollover na, pero hindi pa nakakapag-check ng value. So actually, nung nag-execute yung if statement, si timer 1, nasa 3 na siya, and si PR1 hindi na siya equal kay 0. So, parang ang nangyari ay, we missed our timing. Hindi natin na-check na 0 si timer. So, nagkataon yung rollover was during the time na wala siya doon sa period na kailangan niya i-check. So, parang, supposedly, let's say, visually, kung ito yung ating clock cycle, yung instructions natin execute at a finite rate. And since if statement to, we expect na meron tayong branch operation. So it might take 2 cycles. So let's say, yung timer operation natin takes 2 cycles. Ay, timer cycle. Yung ating if block na-evaluate in this time period, and possibly yung timer value natin dito, F8 siya. Dun sa start nung, or sige, F7. So sa start nung pag-evaluate ng if, F8 siya. And then dito is F9 siya. And dito pala may 0. So during the execution nung if block natin, nung if na instruction, hindi pa 0 si timer 1. Kaso, na-skip na natin si 0. Yung next check niyan is, actually, kaya pa siya makuha no next na check. So actually, ang case na tinitingnan pala natin dito would most probably be, yung 0 natin mag-occur siya. Let's say F9 ka dito, 0 dyan, 1 dito. So F8. So if yung branch equation ay yung branch instruction natin dito nag-evaluate, ito yung knock na katabi ng branch, hindi natin nasasakto yung pag-evaluate ng timer equals 0 doon sa start ng ating instructions. So ayun, nagkukos ng konting mistiming and hindi natin nakaka-capture lahat ng rollovers nung ating input. So yun ang mga pwedeng mangyari pag masyadong mababa yung prescaler value mo. Then, of course, kung masama yung sobrang baba, meron ding mangyayari pag sobrang laki. So, let's try and use the prescaler of 64 and then PR value of 24. So we set this to 2 and then ito is 24. Pag ito naman yung run natin, so note here na yung breakpoint ko is disabled. And we'll just pause the simulation pagka nag-start na. And pause. Mukha naman tama. 24 times 64. Times 64. 1,536. So markers sa start, markers sa end, 1,600. Pwede na. Although, what's interesting here is, parang may mali. If we zoom in here, makakita tayo ng madaming instances ng toggle. So bakit kaya ganon? So step into ko lang to. Siguro if makita natin yung next time na mag-toggle siya. Ayan. So, yung prescaler natin na dito medyo malaki, 64. So, 64 cycles bago mag-increment si timer 1. So, for several instructions, 0 siya and tuloy-tuloy pa rin yung pag-toggle niya. Siguro mas madali ito makita if agad natin siyang ma-check. Para di ako zoom in. So yeah. So yung first time yung mag-toggle bago pagka-start ng ating program. So since 64 cycles bago mag-transition or mag-increment si timer value, meron tayong konting amount of time bago parang mag-settle siya dun sa kanyang final na sagot. And actually, in this case, we wanted to turn the LED on, bigla pala siyang namatay. So this might explain bakit kanina nung tinry kong i-upload yung 64 na prescaler, walang sumisinding LED. Kasi because of the number of toggles every time, hindi siya nagre-result in an LED turning on. So because of the low prescaler value and yung ginagamit natin pang check is timer equals 0, several cycles muna bago siya tumigil, mag-check or mag-toggle. So in this case, parang 1, 2, 3, 4, 5 times siya nag-toggle bago siya mag-settle na mataas siya. Which is around, let's say, may 4 instructions tayo here. And then, so that should be roughly 64 cycles, yung 5 transitions. So, ayun, ano yung gagawin natin? Kailangan ba sakto na lang yung prescaler lagi? What if gusto ko na mas matagal na delay and hindi siya kaya ng prescaler na medyo sakto, katulad nung 1:8 na lagi niya nakukuha si rollover pero hindi siya sumusobra ng pag-toggle. So, ang ginagawa kasi natin doon was to basically poll yung timer 1 value. So, as you may have learned dun sa previous module, we can poll an input and we can also use an interrupt for an input para hindi na natin kailangan alamin kung gaano siya kabilis or gaano siya kadalas nangyayari. So, we can use an interrupt para mag-toggle tayo ng LED every time na mag-roll over talaga. So, hindi natin kailangan i-check yung rollover. The timer can tell us na nag-roll over na siya using the timer interrupt. And if you look at yung ating interrupt table sa datasheet, si timer 1, ito. Ang kanyang vector name is timer 1 vector, IFS 0, and IPC 2. So, ayun, we'll just follow the steps nung pag-implement ng ISR. So, step 1, step 0 is yung multi-vector mode. Step 1 is defining the ISR. So, sa ISR, toggle LED lang yung kanyang kailangan gawin. Then, ayun, since medyo time sensitive yung timer natin, we don't want to clog up yung ating ISR. Gusto natin quick and dirty. And quick, very quick, and agad siya matatapos para makapagtuloy-tuloy pa yung timer kahit mabilis siya. Ayaw naman natin na mag-roll over yung timer during the ISR, kaya gusto natin siyang as short as possible. So yun, timer 1 config no IO. So let's just, I guess we can copy itong dalawang parts na to. Actually, you can copy everything. Stop lang natin ito. And yeah. So let's just define. Ay, dapat hindi ko pala tinanggal si timer config. So let's just define yung pag-toggle ng LED is just ito na yun. Comment out ko muna siya dahil tamad ako mag-type. Paste natin yung interrupt code. And then ang toggle LED is this line right here. IO config are these two lines, configure as output. And yung initial state niya na, well, in this case, on. Can do that. And yan, actually, wala nang laman yung ating while loop dito because yung ISR natin is what toggles the LED. So very important then sa ISR, i-clear yung interrupt flag. So ito, let's run this. Hopefully, I didn't miss anything doon sa copy paste. A user program running. You can just pause it. And then, one smooth transition kahit na yung prescaler natin ay 64. And then, can also use our smallest prescaler. And we should expect a result na pause pa na siya na. Ayan. So, mabilis na siya mag-toggle. So, marker sa start, marker sa end. Yung change is around 50 cycles. Pero 24 lang yung sinet natin. So, medyo malaki pa rin yun. Maybe because of the intrinsic delays, lakihan natin ng konti. I think that's too short of a period na yung ISR natin. Baka yun nga, ito na yung isa sa case na possible na nagkaka-roll over yung timer in the middle of the ISR. So let's just increase yung timer period natin. And should be able to get, yeah, so around 240 cycles yung between pulses, which is yung nakalagay. And yun expected natin na ba? So of course, yung hindi siya exact kasi hindi naman ako sakto mag-pin basically. But you can also add a breakpoint sa loob ng ISR. And then tingnan na lang natin yung stopwatch to get yung actual time if you want. So yun, gumagana ang breakpoint sa loob ng ISRs. So mag-trigger sila ng titrigger siya ng normally. And we can just let it run. And so 250 cycles yung delay between toggles according sa ating stopwatch. So yung pagpin ng kulang siguro dito ng cursors kaya hindi siya exact. Ayan. So ang aking proof ay in the stopwatch. And then ngayon, siguro yung gusto natin kaninang mabagal na blinky-blinky. So from ang prescaler natin ay 15 milliseconds. If we use a prescaler of 64, we should get 400 milliseconds. So pag in-upload ko to, this should be more than noticeable. So in-upload ko na siya sa pic. And yan. If gusto mo time, 400 milliseconds on, 400 milliseconds off. Gusto nating around 500. Pwede natin gamitin yung prescaler na 256 para maging 1.2 seconds. Yung ating blinking. So, 1.2. So, babagal lalo yung blinking. So, mabagal na siya. And, ayun. What else is there to discuss here? Okay. So, our main routine looks relatively lightweight kasi yun, nasa ISR na yung pagtatoggle ng LED. So, our main code is actually free to do anything it wants. So, ito, we have another example din pala wherein ginamit natin siya as a delay na pag si S1 yung pinush, yung delay natin is 24999, so 50 milliseconds, ito 100 milliseconds. Well, assuming na 2 yung prescaler. So, I guess we can have this. So note lang in this example, hindi natin sisindiin na agad si timer. Actually, yung while loop na ito. And then si ISR actually turns off the timer. So let's just define S1 is pushed pagka bits RB7 0. Siguro we should also add here sa ayaw config natin. SB bits SB7 as an input. SB15 as an input. Sayang naman yung mga comments pa dyan. I-update. So, RB13 here. Turn on LED. So that's just this line. So initially off natin siya. And then I'll just add a loop here so that once lang siya matitrigger. button test. So hanggang hindi na-release si button, hindi siya mag-move on doon sa code. Dito naman RB. So medyo crude, medyo walang debouncing. Pero I think this would work. Okay, so wala ba't hindi siya mag-isa? Just hindi mag-isa. Lat E0. It's actually not turning it on. Pero that does not explain why it's on. Kasi yung ISR natin is toggle pa rin. Let's make that 0. And on pala natin yung timer by default. Something to note, if you want to use the interrupt as a fixed delay, make sure to turn it off or not turn it on when you don't need it. Blue. So notice na mas matagal pag pinrest ko si RB7, medyo short na delay. Pag si RB13, it's a longer delay. Ito mo? Right. And then we can also observe this sa ating logic analyzer with our stimulus. Pero babaan ko lang yung prescaler since 10,000 lang yung limit natin. So here actually recommended is 249 lang din yung PR and 499. 499 yung ating longer delay. So let's just set yung configuration natin to the simulator. And then add lang tayo ng stimulus natin. RB7. Let's just add it as toggle. Okay. And then RB13 as toggle then. Then let's run the simulator here. add din natin sa logic analyzer si RB13, RB7 at si RB13 to monitor yung kanilang output. So, pareho silang 0 as of now. So, let's just toggle din muna sa ating stimulus. So, pareho silang high. So, yan. Yung ating loop is just nagsiskip sa pagpo-poll. So, let's, for example, press RB7. Na-press si RB7. And so, hindi na si LED. So, toggle back lang natin siya dyan. And, ayun, namatay din siya eventually. And then, let's toggle RB13. And yun, nag-activate yung ating delay. And then, let's just allow it to
I found this on the web.
simulate. Nag-activate si Google Assist. And so noticeably, mas malaki yung delay when we pressed RB13, actually. Yeah. Almost, hindi pala almost, actually double. So from here to here, 270 lang, around 250 yung sinet natin. If we remove this, and then dito naman, nasa 500 naman yung depth. So, yun ang stimulus with the simulator timers. So, going back, your next exercise will then be is to just implement the 2-bit timer na ayan, nagka-count siya starting from 11, 01, 10, 00. So, depending on how you look at it, yung countdown. So, si LED2 yung bit 2. So, starting from 3 to 1 and then 0. So, yan. Ang requirement is every second nagbe-blink si LED1 and then si LED2 is magbe-blink every time na mag-on si LED1. So pag nag-on siya, mag-on siya. On siya, toggle. On, toggle. On, toggle. So for those na wala pang DevBoard, yung 1 second in real time and consider as 1 milliseconds dun sa simulator para pwede nyo bawasan yung clock cycles ng delay and makita nyo siya sa simulator. So either option naman na ipasa nyo, should be considered. So I'll stop this first recording there and then we can work on the first 2 exercises muna before moving on dun sa ating next na section. So actually, ito yung end ng first module. So, okay. See you next time.